Can you hear me everyone? Am I audible? Okay, so let's start the class. The topic of our interest here is equilibrium. So without wasting much time, let's start the class with the previous question papers, right? Okay, look at the first question here. 1 mole of N2O4, that is in gaseous state, at 300 Kelvin is kept in a closed container. So this is under 1 atmosphere. It is heated to 600 kelvins when N2O4 gas decomposes to here. This part. When N2O4 decomposes to NO2. So if the resultant pressure is 2.4 atmosphere, the percentage dissociation by mass of N2O4 is how much of percentage is dissociated. Okay, so this is one of the previous question papers which was asked, and you have the options here: 10%, 20%, 30%, 40%. So what is the question is, here they said that which is at 300 kelvins, one thing which is important, 1 mole. Now this is in closed container, which means it has established the equilibrium, right, under 1 atmosphere. So when it is heated to this temperature from 300 to 600 kelvins, what is happening? It is decomposing. At 300 kelvins there is no decomposition, but once the temperature is increased, there is decomposition in a closed container. So what you need to find out, if the resultant pressure, here the pressure is 1 atmosphere, if the resultant pressure is 2.4 atmosphere, then the percentage dissociation, how much of percentage has been dissociated if the pressure has been increased from 1 atmosphere to 2.4 atmosphere. So what is your answers, guys? So your answers please. Okay, let's see. For example, when N2O4 is dissociated to NO2, that is 2 equivalents of NO2, say this is 1 minus alpha and this is 2 alpha. What is alpha? Degree of dissociation. So the temperature 600 to 300, that means initial temperature was 300 when it is increased to 600, which means here the volume is kept constant. So the P2 is found to be 2 atmosphere. After dissociation of N2O4 at 600 kelvins, then you can see that partial pressure of N2O4 is 2 into 1 minus alpha, that is 2 minus 2 alpha. Here this is giving you 4 alpha. Are you getting? Okay, so someone has given me the answer as 30, right? Let's see. See, you have total pressure is 2 minus 2 alpha plus 4 alpha, which is 2 plus 2 alpha. This is equal to 2.4. That means this was given when the pressure has been increased from 1 atmosphere to 2.4 atmosphere. This should be equivalent to 2.4, which means alpha is 0.2. So the percentage decomposition is 20%. Are you getting, guys? Are you able to understand? The percentage decomposition here is 20%. That means answer is B here. Okay, when the pressure from 1 atmosphere to 2.4 atmosphere has been increased. Got it? This is how you need to calculate. This is a subjective question which was asked from the past papers. This is a subjective question. So moving on to the next question. Right. In which of the following equilibrium the value of Kp is less than Kc? What you have to do? What is the relation between Kp and Kc? In which of the following equilibrium the value of Kp is less than Kc? You need to know what is the relation between Kp and Kc. And moreover, I will give you the hint that this is a options, that means you have more than one option. The correct answer has more than one option. How do you find out it? How do you find out the relation between Kp and Kc? Right? You can see Kp equals to Kc RT delta n. Right? What is delta n? Delta n is the concentration, that is the equivalence of number of moles of gaseous products minus gaseous reactants. Products, the gaseous products minus reactants. This is delta n. Now, if Kp is less than Kc, if delta n is less than 0, very simple, you should know only this thing, Kp is less than Kc when delta n is less than 0. How do you calculate delta n? How can we calculate delta n? Look at this, calculate the delta n. Yes guys, this is live class, it is not a recorded one, this is a live class. Do you have any queries? So what is the delta n for this one? This 2 minus 1, this is delta n is 1. Here delta n equals to 2 minus 2, which is 0. Here delta n equals to 2 minus 4, which is minus 2. Next you have delta n equals to 2 minus 3, which is minus 1, which means you have two cases, that is in case of C and in case of D, the delta n values are less than 0. If the value of delta n is less than 0, then Kp will be less than Kc. Is it clear to you? Right? Okay, why B will be the answer? You have 2 moles here, 2 moles here. Delta n 0, delta n should be less than 0. Are you getting? Any other queries? Okay, so you have 2 options. Moving on to the next question, guys. Okay, for the reaction phosphorus trichloride, chlorine gas, phosphorus pentachloride. Here the value of Kp at 250 degrees centigrade is 0.61 atmospheric pressure. Now the value of Kc at this temperature, this is also one of the past paper subjective question. Okay, look at this question. You have been given with the equation, there were the value of Kp was given to you. They are asking you to find out the value of Kc. So what you should know? The same as that of previous, that you should know the relation between Kp and Kc. Kp equals to Kc to RT delta n. So what is Kp value? Kp equals to 0.61, which is equal to Kc. What is the R value? R is universal gas constant. So here this is 0.821 times, what is T here? The 250 degrees. 250 degrees centigrade convert into kelvins, right? That means add somewhere you will get 523. And delta n, what is delta n? Delta n is here you have 1 then 2, 1 minus 2 you have minus 1. Is this clear? Is this clear? You need to substitute to get the value of Kc. So, moving on to the next question. Yeah, this is a beautiful question. For the decomposition reaction, ammonium acetate, you have given it. Ammonium acetate is decomposed to ammonia and carbon dioxide gas. So, the Kp value is given as 2.9 into 10 raised to minus 5 cubic atmosphere. The total pressure of gases at equilibrium when 1 mole of ammonium acetate was taken to start would be. So, what do you have to do? They was given with the decomposition reaction, the Kp value was given to you, the total pressure of gases at equilibrium when 1 mole was taken to start. If you have taken with 1 mole, you have been given the options here to find out the pressure. How do you start with? Just try. Look at this, ammonium acetate, where you have 1 equivalent, this is 2 equivalents and this is 1. The Kp value is 2.9 into 10 raised to minus 5 cubic atmosphere if P is the total pressure at equilibrium. If P is the total pressure at equilibrium, then Kp will be, you should know this, 2P by 3 whole square plus P by 3. So, this is where you get P cube equals to 27 times the value of Kp here by 4. So, you have P cube, which is the value after substitution you get this value, then P equals to cube root of this. So, what is the answer? You have 0.0582 atmosphere. Look at this, 0.0582. Is it clear to you guys? This is the how you have to follow the substitution to find out the P value. So, look at this. The next question, for a system at equilibrium, which of the following are correct? Again, the question from the past papers where you have more than one correct answer. What is given to you? The first one, d natural log Kp by dP to the temperature is minus d by dP to delta G by RT. The next question, the next option, log Kp equals to 1 by 2.303 R delta S minus delta H by T. Now, you see that on increasing the temperature of an endothermic reaction, the equilibrium shift in the forward direction because K increases. On increasing the temperature of an endothermic reaction, the equilibrium shift in forward direction because Q decreases. Okay, let me highlight here. This is K is increasing, Q is decreasing, endothermic reaction. Both cannot be the answers, first of all, only one can be the answer, right? So, firstly, my question to you, what is the difference between K and Q? Okay, so any other guesses? Someone is saying A, C, D, okay, A, B, C, right? So, what is the difference between K and Q? Someone can answer. K and Q. K, you are calculating the concentration at equilibrium, whereas Q, it is not at equilibrium at any given point when the reaction is processing. When the reaction is moving forward, at any given point of time, if you are finding out the concentration, then it is the value of Q, right. So, that is the main difference between the K and Q, right. The difference between K and Q is when you are finding out the concentration exactly at equilibrium, then it is K. But if you are finding out the concentration of any given reaction at any given point of time, not at equilibrium, any point of time, then it is Q. You are finding out the Q value. That is the main difference between the K and Q. So, here look at this. We already know delta Z equals to minus RT natural log Kp. This is the formula delta G, right. So, you have dl and Kp by this equals to differentiation of this one. So, I can say is the correct option. Look at this, RT ln Kp here. Okay. And we also know that delta G equals to delta H minus T delta S. So, delta Z equals to 2.303 RT log K. That is the reason why log K equals to 1 by 2.303 delta S minus delta H by T. You have to know the simple substitutions, of course, but these are the basic formulas, basic equations which you must be knowing. Now, that is the reason why B is the correct option, and this is very interesting. In endothermic reaction, changing temperature, K changes but not Q. That is what if you are thorough with the Le-Chatelier's principle and its factors where exactly it is affecting, we will definitely answer this. Is it clear to all of you? Yeah, I will repeat it for you definitely. So, usually endothermic reaction, what is going to happen? When you apply the Le-Chatelier's principle at equilibrium, when you increase the temperature, the endothermic reaction changes. That means it moves the reaction forward direction. At equilibrium, when the temperature has been increased, that means change in temperature, the equilibrium changes, right. The equilibrium changes, but it is not for Q. Is that clear to you? See, that is what I am saying you. What is the difference between C and D? C is nothing but, see, you know about Le-Chatelier's principle, right? The whole principle we are studying at equilibrium. You have a reaction at equilibrium. Now, if I disturb this equilibrium, what is going to happen? Either it may move like this or the reaction may move like this, right. So, you have different factors wherein which if I add temperature, how can you disturb? Either by increasing the temperature, either by increasing the concentration of reactants or products, or increasing the pressure, right. This is how I can disturb an equilibrium. Now, the system moves in such a way that it has to balance, that means it has to regain the equilibrium. This is in case of equilibrium what we are speaking. Whenever you are speaking about the equilibrium, that is the value of K, but Q is something which we speak during non-equilibrium conditions. We need to find out the concentrations when the reaction is not at equilibrium, but here when the reaction is at equilibrium. Okay, yeah. Okay, so the next question over here, yeah, this is something related to ionic equilibrium. In 1 liter saturated solution of silver chloride, you have a solubility product, that is AgCl is 1.6 into 10 raised to minus 10. 0.1 mole of CuCl, cuprous chloride, the solubility of product of this is 1 into 10 raised to minus 6 is added. The resultant concentration of Ag plus in the solution is 1.6 into 10 raised to minus x. So, what is this x? What is the value of x? Subjective question which was asked in Advanced 2011. In 1 liter saturated solution of silver chloride, you have solubility product of silver chloride that is given, then solubility product of cuprous chloride is also given. So, what is the resultant concentration of Ag plus in the solution is? So, you need to find out what is the value of x. How do you see? Look at this, the solubility product, that means at equilibrium Ag plus ions are x and chloride ions are also x. Whereas for cuprous chloride you have Cu plus, where you have taken as y, chloride ions also y. That means if you say the net chloride ions in the solution is x plus y, you have here there is chloride ions, here also there is chloride ions. This is x plus y. If you see KSP, that means solubility product of AgCl is 1.6 into 10 raised to minus 10. Here Ag plus, which is only x here, Ag plus, that is this x is this one, plus x plus y, you have taken chloride both in the solution. So, I can say x into x plus y is 1.6 into 10 raised to minus 10. This is given here for AgCl, because you are asked to find out the resultant concentration of Ag plus ions. So, we have taken this 1.6 into 10 raised to minus 10. Now, what happens? Ksp of CuCl is 1 into 10 raised to minus 6, again it was given in the question. So, this is Cu plus and Cl minus, again the same thing, x plus y will be common, but instead of x, that is for Ag plus, here you have y for cuprous ions. Is it clear up to here? Right, this is how you have to approach, this is how you need to write down for the subjective questions. Now, from equation 1 and 2, this one, from this one as well as from this one, here what we have identified, x by y is 1.6 into 10 raised to minus 4. We have 10 raised to minus 10 for Ag plus ions, 10 raised to minus 4 for, sorry, minus 6 for cuprous ions. So, here it is 1.6 into 10 raised to minus 4. Now, you can see y equals to 10 power 4 by 1.6x. A same thing, if you see, putting the value of y in equation 1, we can get like this. Very simple substitution, x plus 10 power 4 by 1.6x, which is 1.6 into 10 raised to minus 10. Now, this gives you 1.6 into 10 raised to minus 7. Look at this, this is the question. So, x will be 1.6 into 10 raised to minus 7, that is the net resultant concentration of Ag plus ions. Is it clear to you? You have to do simple substitution where x by y is 1.6 into 10 raised to minus 4 and y is 10 raised to 4 by 1.6x. So, upon substitution you will get this value. Here taking x square, 10 power 4 by 1.6 is this value, x square is this one and x is the half of it. Okay, guys. Look at this, again you have one more question, Advanced 2010. A subjective question again. the total number of diprotic acids, ionic equilibrium, the total number of diprotic acids among the following. Give me your answer. I will give a minute time for you.
Reciprocal, I think it is a reciprocal. I'm asking.
What is your answer? How many have diprotic acids? By the looking at the structures, can you find out what are diprotic acids? Is it possible or not? Okay, 4 or 5, right. Diprotic acids means you should have 2 dissociable protons. By looking at the structures, you should be able to identify, right, which are attached to the most electronegative element and which are feasible. That means the bond between those two elements should be very weak so that the proton is released into the solution. Okay. So, here I will show you 6 diprotic acids are there. Look at these structures. If you say sulfuric acid, where obviously this you should be knowing, you have this OH and this OH. So, if it is blurred, I am writing down here. So, you have OH where this proton is dissociated and you have OH, this proton is also dissociated. So, 2 protons that can dissociate diprotic acid, whereas this one you have H3PO3. Though there are 3 protons that are present, but only 2 protons are dissociable because those are attached to most electronegative elements, that is oxygen. You have P here, double bond O. The next you have H2 here, these 2. Yes, yeah, you have 6. Then here there is one more, these 2. Again you have chromic acid, which is a diprotic acid. Well, here also sulfurous acid, H2SO3, sulfurous and sulfuric, both are the diprotic acid apart from phosphoric acid and various other chromic acids also. So, this is the examples for diprotic acids. Among the following, the total number of compounds whose aqueous solution turns red litmus paper blue. What does it mean? This is the question which was asked in the advanced 2010 subjective question. Red litmus blue, which means the solution should be, that means these should be basic in nature. So, which are these are basic? Which of these are basic? That is what the question is all about. The following total number of compounds whose aqueous solution turns red litmus paper blue. That means which of these are basic in nature? How many are basic in nature here? Yeah. So, there was a question who was asking you, why is the hydrogen? See, this hydrogen cannot be dissociated because the electronegativity difference between these two is quite less. Hydrogen that is attached to most electronegative elements like chlorine, fluorine, oxygen, nitrogen, those what happens? They pull the electrons to this side, which means this bond is very weak. This bond is very weak, which means the electrons are present very close to the oxygen, not, that means the electrons are not shared equally. The electrons are present very close to the oxygen, not towards hydrogen. So, this proton is very weak. Is it clear? Okay, so what about this? So I have got answer as 3. Okay, so any other answers? 5. Okay, I'll show you. KCN, potassium carbonate, lithium cyanide, or basic in nature. That means here, though we are studying this in the in the equilibrium, ionic equilibrium chapter, you should have a little bit knowledge about the inorganic chemistry as well, because here the basic nature of carbonates increases down the group usually. So potassium carbonates is a basic. Even that, not only that, basic nature usually increases if you move down the group. Got it? So in the same way, and the compounds of cyanates are weak bases. Cyanates, what are cyanates? Potassium cyanide and lithium cyanide. Compounds of cyanates are weak bases. Whereas for carbonates, for the first group elements, if you move down the group, the basicity increases. So 2 here, that means 2 different class of compounds. I can say here potassium cyanide or lithium cyanide, and you have potassium carbonates. Look at this, what are left over? Sulfates, this is salt, ammonium nitrate is salt, those are salts. This is acid, oxalate, C2O4. What does it mean? C2O4. C2O4 is an oxalate, that is acid. Here nitrate, salt, ferric chloride, salt. You have salts and acids. From salts and acids you are picking out the basic compounds. Is it clear to all of you? Any other queries? See, what are the most important topics that we have to cover from the equilibrium chapter? So 2 things, one is chemical equilibrium, ionic equilibrium. A chemical equilibrium, something you should know about what I have shown you. The Kc, the Kp, the problems based upon these, as well as Le Chatelier's principle, which is quite important. Apart from that, in the ionic equilibrium, some knowledge of the electrochemistry is also required, some knowledge of inorganic chemistry is required to solve the questions here. Acid concentration, then buffer solutions. So these are very important, and finding out the solubility products. So these are the some things which are very important for the exam point of view in the equilibrium chapter. Okay guys, that's all for the today's session. Let's come up with some more important topics in our next session, right? Thank you.